All right, guys, today we are going to go over covalent names and formulas. In my other video, you can check out how to name ionic compounds and write ionic formulas. This is going to focus just on covalent. In order to be covalent, it needs to be made of two nonmetals. It's important that we know where the nonmetals are located on the periodic table. We want to focus on the staircase line that you see here. This staircase line is our divider line between metals and nonmetals. Everything to the right of this staircase is considered a non-metal. Everything to the left of the staircase is considered a metal. So my metals are here as well as here and underneath the staircase here. So when we talk about covalent compounds will be made only of the elements found in this region of the periodic table. Furthermore, we know that noble gases are stable already, so we will not find these noble gases in a covalent compound. Because they're both nonmetals, they are going to share their electrons. We see that nonmetals tend to have a high electronegativity, and for that reason, neither nonmetal is strong enough to pull an electron away from the other. So instead, they settle on sharing. Now, this is important because this is where they are different from ionic compounds. When they share electrons, nobody gains and nobody loses electrons. So there is no overall charge in the compound. That means that when we are writing covalent names and formulas, there are no charges to deal with like we would see in an ionic compound. Because we don't have any charges, we're going to need to use prefixes in order to indicate how many atoms we have. I have all of the prefixes 1 through 9 listed here. We are going to use this set of naming rules in order to name our covalent compounds. So whenever we have a covalent compound, you're going to start by naming the first element and using a prefix, one of these prefixes listed here, to indicate how many of the atoms are present. Then you're going to name the second element, also include a prefix from the list here to indicate how many atoms are present, but then you're going to put an IDE ending on the end of that second element. Let's look at a few examples. The first example we're going to look at is N2Cl2. First thing we want to notice is that these are both nonmetals. Once you've identified that they're both nonmetals, we're going to use the rules above in order to name it. The first rule says name the first element with the prefix. I'm going to find N on the periodic table, and that is nitrogen. Then I'm going to use a prefix to indicate how many nitrogens are there. Since I have 2, I'm going to use the prefix di. Dinitrogen. Then the second rule says to name the second element with a prefix and an IDE ending. So chlorine is another nonmetal. We're going to use the prefix di to indicate that we have 2 of them. And then rather than writing chlorine, we're going to change the ending to chloride. So my prefixes are indicating how many atoms are present in the compound. Let's look at our next example. CO. C and O are both nonmetals once again. So we know that we're going to need to use our covalent rules listed above. We're going to name the first element with a prefix, but notice that we do not use mono on the first element. So if I look at my carbon here, the first element, there's nothing written. That indicates that there's only one of them. But we don't need to write mono on the first element. We're just going to simply name this carbon. Now I go to my second element, which is oxygen. I name the second element with a prefix to identify how many and IDE. We do use mono on the second element. So this is going to be monoxide. Again, we change that ending to IDE. Rather than putting 2 O's together, we typically drop one of them. Instead of monoxide, we write monoxide. Let's take a look at another example. CO2. Again, I'm going to start by identifying that they are both nonmetals. Once I've identified they're both nonmetals, I'm going to name the first element and indicate how many with a prefix. This time there's only 1 carbon again, so we do not use mono on the first. I'm simply going to name this carbon. When I go to the second element, this time again it's oxygen, but notice that I have 2 of them. Because I have 2 of them, I'm going to use the prefix for 2, which is di, and this is carbon dioxide. I'm always going to change the ending of the second element to IDE. Let's look at one last example. I have chlorine as my first nonmetal and oxygen as my second. We start by naming the first element with a prefix to indicate how many atoms we have. So there are 2 chlorines here. The prefix for 2 is di. And I'm going to name my first element normally, dichlorine. And then I move to the second element. I'm going to name the second element with a prefix and that IDE ending. So I have 7. The prefix that corresponds to 7 is hepta, and oxygen becomes oxide. Let's take a look at a few examples where we go the other direction and we're given a name and have to take that and translate it to a formula. The first example we're going to look at is dinitrogen trisulfide. Again, I'm going to start by making sure that they are both nonmetals. If they are both nonmetals, then I know it's a covalent compound, and I'm going to use prefixes in order to indicate how many. The element nitrogen is on the periodic table, and its symbol is N when I find it. Di means that I have 2 of them. If I look at my second element, sulfide. Sulf, the only nonmetal that starts with sulf, the root of the word, is sulfur. Sulfur has a symbol S, and the tri indicates that I have 3 of them. There's no need to balance charges like we see in ionic compounds because remember, these guys are sharing their electrons. No electrons are gained or lost. Let's look at one more, carbon tetrachloride. Again, both of these are nonmetals, and carbon has the element symbol C. There's no prefix here. If there's no prefix written on that first one, that's going to indicate that we have only 1 of them. Then I'm going to look for the element with the root word chlor. So chloride is coming from chlorine, which is Cl. I'm going to write the symbol, and then I'm going to use the prefix to identify how many I have. CCl4. I hope that helped clear up how to write covalent names and formulas. Please check out my other videos, and thanks for watching.